This is lesson 8-4C from the Algebra Readiness textbook. Our learning target today is to learn about direct proportions. We're going to learn how to identify a direct proportion and how to write an equation for a directly proportional relationship. First, we're going to try to explain what is going on in this graph. In order to describe what's happening in a graph, I read my x and my y axis and my title. My title says number of hats produced in a factory. My x-axis is going up in increments of 1 minute and is labeled minutes the factory runs. The y-axis is labeled hats produced, and the y-axis is going up in increments of 20. The graph itself looks like it's going up and to the right, which means that as the number of minutes the factory runs, the more hats produced. The longer the factory runs, the more hats are produced. Okay, let's take a look. Let's take a look at the origin at 0, 0. Do you see that there are 0 hats produced at 0 minutes? And you can keep reading those ordered pairs. 1, 20. At 1 minute, 20 hats are produced. At 2 minutes, 40 hats are produced. At 3 minutes, 60 hats are produced. So the number of hats produced varies directly with the number of minutes the factory runs. That's what it means when it goes up at an even increment. Every minute adds 20 hats. So when the values of x and y vary directly, we call this a direct proportion. So that's what a direct proportion is. With a direct proportion, the unit rate will always be the same. Now, as a reminder, the unit rate is finding out how many for one of something. So in this case, how many hats are produced in 1 minute and for every 1 minute. So if I said 100 hats are produced in 5 minutes, you would take 100 divided by 5. That's your unit rate. We learned that in a previous chapter. So let's calculate out our hats per minute. We can take 20 divided by 1 and get 20. 40 divided by 20 and get, 40 divided by 2 and get 20. 60 hats produced in 3 minutes, 60 divided by 3 is also 20. 80 hats produced in 4 minutes is still 20 hats per minute. And 100 divided by 5 is still 20 hats per minute. So in a direct proportion, there are certain things that are always the same. One thing that will help you to identify a direct proportion is if the unit rate is the same for every single entry in both the table and the graph. We find that 20 hats are produced each minute. The hats are produced at a constant rate. With a direct proportion, the y divided by x, or unit rate, will always equal the same value. That's a pretty important one to write down in your notes. With a direct proportion, the y divided by x will always equal the same value. Okay, so let's write these notes down. When the value of y divided by x is a constant rate, there is a direct variation between x and y, or a direct proportion. This constant value has a name, and we're going to call that the constant of proportionality. We represent the constant of proportionality with the letter K. So y divided by x equals K. And K will always be the same for all values of x and y. So when we took our number of hats and divided it by the number of minutes, we always got 20. So in our last example, our K value was 20. A direct proportion can always be written in this format. Y equals Kx, with K as the constant of proportionality. So you could have taken that equation and written y equals 20x. So I want you to write down that equation format, y equals kx. And know that whatever your constant is, whatever your unit rate is, that's the coefficient of x. And it works every time. All right, so in our hats produced, that looks like y equals 20x. So we said that the number of hats produced is directly proportional to the number of minutes the factory runs. A direct proportion will always be a straight diagonal line on a graph. So if you were trying to identify, is this graph a proportional relationship, you would simply be looking for a straight diagonal line on a graph that goes through the origin. It has to go through the origin. The constant of proportionality here tells us that for every increase of x by 1 unit, the y increases by 20 units. That is also our slope. So take a look. An increase of 1 minute, increase 20 hats. An increase of 1 more minute, an increase of another 20 hats. And so on and so forth. It's also important for you to write down and memorize that a direct proportion will always touch the origin, because when x equals 0, y must also equal 0. That's the only time when y divided by x, in this example, does not equal 20. So let's write this down. Direct proportion graphs. Number 1, always are a straight diagonal line on the graph, and number 2, always touch the origin. Let's look at our 4 graphs. The first graph in the upper left, about mass of butter and amount of saturated fat, is a direct proportion because it meets the criteria of being a straight diagonal line through the origin. Right below that is another graph about time and distance. That is a straight diagonal line going through 0, 0. That is also a direct proportion. The next graph that we see to the right of that is a straight red line, right? A straight diagonal line through the origin. The last graph that has the big words no on it, although it is a straight diagonal line, that diagonal line does not go through the origin, and therefore it is not an example of a direct proportion. So the following 3 graphs show the relationship between the amount of an item purchased and the total cost. The total cost is directly proportional to the number purchased. We're going to practice on writing an equation in the form for each of these graphs in y equals kx format. In our first example, let me see. First, we need to determine the constant of proportionality. An increase of 1 unit indicates an increase of $2. An increase of 1 unit purchased is another increase in $2. So for that means that my unit rate is 2, because when I take the y value divided by the x value, I get 2. 2 divided by 1, 4 divided by 2, 6 divided by 3, 8 divided by 4, 10 divided by 5, they all equal 2. So you just put that constant number before x. Y equals 2x. Done. If y equals 2x is true for all values of x and all values of y, because the relationship is a direct proportion, and you can check it. So look at some ordered pairs on the graph. Take the y value, that's the second number, and divide it by the first. 18 divided by 9 is 2. 12 divided by 6 is 2. Here we can tell this is a direct proportion in graph B because the graph touches the origin and increases at a steady rate. It is a straight diagonal line. We can use any point on the graph to determine the value of K. Remember, your K value is your unit rate, Y divided by X. So you could take the first ordered pair of 0.2 divided by 2, or 0.4 divided by 4, 0.6 divided by 6, 0.8 divided by 8, or 1 divided by 10. Either way, you get a K value of 0.1 or 10 cents. And it's the same amount for every one of those ordered pairs. Notice that the table here that's in that I showed you is actually just a list of the ordered pairs. I just listed them out so you could see Y divided by X a little clearer. So now writing the equation Y equals KX should be much simpler. We're just going to write Y equals 0.1X. Each item purchased costs 10 cents. The total cost Y is the number purchased, X, multiplied by the constant price of 10 cents. For letter C, I would like you to pause the video. Try to find an equation to represent this direct proportion. When you're finished, continue the video to compare your answer to mine. To begin, I'm going to read a couple points off of my couple ordered pairs off of my graph. I already see that this is a straight diagonal line going through 0, 0. So I have a good feeling this is directly proportional. I have the first ordered pair of 125 and the second ordered pair of 250. When I find the unit rate, Y divided by X, I get 25 divided by 1 is 25, and 50 divided by 2 is also 25. This tells me that each item is $25. Y equals 25X is the equation. So which title belongs to which graph, and how do you know? Number 1, cost of gumballs purchased. Number 2, cost of sweatshirts purchased. Or number 3, cost of pizza slices purchased. Pause the video and match the titles 1, 2, and 3 with graph A, B, or C. Okay, I see that the cost of gumballs would be about 10 cents per gumball, so graph B makes the most sense. In Title 2, cost of sweatshirts purchased, a sweatshirt would most likely be costing around $25. So graph C, Y equals 25X, would be the best graph for Title 2. Then for Title 3, cost of pizza slices purchased, graph A would be the best representation because Y equals 2X or $2 per pizza. The constant of proportionality tells us the relationship between the total cost and the number of items purchased. The constant 10 cents and $25 is the unit rate for purchasing each item. And so we use that to help us to figure out which title matches which graph. Now we need to be able to determine a direct proportion from a table. In the same way that we took an ordered pair and we put them in a table, you're going to do the same thing if I just give you the table. So to determine if a direct proportion exists, you must see if the ratio between Y divided by X, or the unit rate, is the same for all ordered pairs. Now, you may use a calculator, but you do need to check every entry in the table. $156 of profit of 13 guests would be 156 divided by 13, or 12. 240 divided by 20 is also 12. 480 divided by 40 is also 12. So $12 per person seems to be a constant unit rate because there is a direct relationship between the number of guests and the money that the catering company makes. We say that this is a direct proportion. there is a profit of $12 times the number of guests, or y equals 12x. Notice the equation stays the same. Y equals your constant rate times x. 12 is also your slope. So the total money made equals your constant of proportionality, 12, times the number of guests, x. So that means that for every one guest, the caterer makes $12. So the number of people directly affects the amount of money made. That is a direct proportion. So the first person is $12 of profit for the catering company. And so are every person thereafter. You can even see in a graph that the table makes a direct proportion. Notice it's a straight diagonal line going through 0, 0. And if you read any ordered pair off of this table, you could look back at how we did it before. 120 divided by 10, 240 divided by 20, 480 divided by 40, and you get $12 per customer. And this is important. If 0 customers come, or if the event hall is closed for the night, the caterer makes $0. That is the origin. So a direct proportion will always touch the origin. Let's try this one. I want you to pause the video and calculate out if the table shows a direct proportion. The table is about money that Heather made at work this week. X is the number of hours she works, and money made is Y. Find the Y over X and see if it's a constant amount. Pause the video and continue when you're done with your calculations. All right, when I take $77.50 divided by 5, I get $15.50. When I take $124 divided by 8, I also get $15.50. Remember I told you need to check every entry in the table. It's important because look what happens when she worked 6 hours. 105 divided by 6 is $17.50. Right there, we now know this is not a direct proportion. For a direct proportion, all pairs must have a constant ratio. So this is an example of one that is not a direct proportion. You can see that at 9 hours and 7 hours is also not a direct proportion. The amount of money that Heather made is not directly related to the number of hours that she works. Can you think of a real-world situation that this data might represent? This is a graph showing the money that Heather made at work this week. Notice the graph is not a straight diagonal line, and the graph would not go through 0, 0. Since it's not a direct relationship, Heather does not make the same amount of money each hour. Perhaps Heather works for tips, or perhaps she works for commission. Try this one. Sugar used to bake brownies. You can calculate the batches of brownies and the cups of sugar used. See if you can see if the relationship between cups of sugar used and batches of brownies made shows a direct proportion. Pause the video and calculate your unit rate. Also, write the equation if it is a direct proportion. All right, when we calculate the y divided by x, I get 1.75 cups per batch. In the next table entry, 8.75 divided by 5, I get also 1.75 cups per batch. 14 divided by 8 is also 1.75 cups per batch. And lastly, 26.25 divided by 15 is also 1.75 cups per batch. This table shows a direct relation or direct proportion because all pairs have the same ratio of y divided by x, or a constant of proportionality. Remember, we called 1.75 our k value. the total amount of sugar is 1.75 times x. Y equals 1.75x. Our y equals whatever your constant or k value is times x. And then we can verify it by looking at it on the graph. I see it as a straight diagonal line going through 0, 0. Pause the video, try this one. All right, hopefully you figured out the unit rate and an equation. If it would apply, we're going to find the unit rate. What would the change in this student's math grade be if they have missing assignments, per missing assignment? It looks like negative 1.75 points were deducted for 3 missing assignments. 12.5 points were deducted for 5 missing assignments. 30 points were deducted for 12 missing assignments, and 37.5 points were deducted for 15 missing assignments. The change is negative 2.5 points per missing assignment. Because that number, y divided by x, is the same, constant of proportionality, this table does show a direct proportion. We can write the equation y equals negative 2.5x. A constant of proportionality can be a negative number. That's the k value. There is still a direct proportion between x and y. So to write an equation to represent that situation, replace the k value with negative 2.5. Y equals negative 2.5x. Now the graph, notice it still crosses at 0, 0, and this time it's a straight diagonal line. It just has a downhill slope. For every homework assignment missed, 2.5 points are deducted from that student's grade, or their homework grade changes by negative 2.5 points. Again, if you miss 0 homework assignments, your grade won't change, 0, 0. Then you can read all of the ordered pairs and see that if you took the y value divided by the x value, you would still get a constant negative 2.5. Okay, the last one. Write an equation for a direct proportion containing the ordered pair of r is 3, if an ordered pair r 3, 6. Well, at this point, if I told you it's a direct proportion and you have an ordered pair, you can simply take the y value divided by the x value. So you can take 6 divided by 3, 6 divided by 3 and get 2. Y equals 2x. I don't know why my pen is not writing on this. The next one, write an equation for a direct proportion containing an ordered pair of m is 4, 5. Pause the video and try the next two, then come back to continue to check your answer with mine. All right, we know that the value of y divided by x, or the constant, is the same in a direct proportion. It's telling us this is a direct proportion. So you can simply take 5 divided by 4 to find your k value of 1.25. So you would write an equation, y equals 1.25x. Again, the equation is y equals 1.25x. And lastly, write an equation for a direct proportion containing the ordered pair of m, point m, which is 2, 9. You would simply take 9 divided by 2 in your, you probably can do that in your head, and you get 4.5. Your k value is 4.5. The equation would then be y equals 4.5x. Y equals 4.5x. And that would model the relationship of that direct proportion. All right, so today you learned about a direct proportion in a table, in a graph, or given an ordered pair. You learned that that there's a constant relationship between x and y, and you learned that a graph is a straight diagonal line through the origin.